It's fantastic to be here. Not the least reason being, I live in Chicago, and if you look here, the weather in Chicago is -2, very cold, and in Taipei, it's a beautiful 29 degrees, so I'm super excited to be here. But it's not just that. I mean, it's a fantastic opportunity, so once again, thank you for all the organizers. Thank you most importantly for all of you to be here, for your interest in Connect. What I want to do actually is sort of pick up exactly where Stuart left off. Normally I sort of get into my slides, but since I have internet access, I wanted to show you something really quickly. The site that Stuart mentioned, connectforwindows.org, basically is a great resource, and I see a lot of you here have laptops, so I want to make sure to point this out in case you want to get the source code and or the SDK and play along as we proceed. I'm on internet. It worked there just 5 seconds ago. Everything was working great, and now it won't go. This is crazy, actually. Let me see if I fold it up. Okay, so the key, we'll see if it comes up, but the key thing I wanted to point out was on the tab where it says resources, you can actually see all of the other Connect projects from the Channel 9 gallery that Stuart was talking about. So the goal of my session, there it is, thank you. So obviously this is the home page, right? And you can download all of the SDK by clicking that one link, depending on if you have a 32-bit or a 64-bit computer. It's just one download, and it's a very reasonably sized download. It's like 20, 25 meg or so. But if you get over to the resources section, this is fantastic because it has a bunch of really cool links to for additional follow-up. So you have a few links to the forums. If you have questions about some features, the forums are a great way to see if somebody else has had the same question and if it has already been answered. But more importantly, it gives you a couple of links to the project gallery and quick starts. And I'm gonna just wait for these to come up. So this is basically what Stuart was talking about. This is a gallery of about 100 different applications from around the world built on the Connect. And most of these have the source code, right? So the really cool part is actually you can look at a full-fledged application that somebody else has built, including the source code. And as most of us in software realize that one of the best ways to learn is by looking at other people's source code, is by looking at samples. So definitely take advantage of that. So if you're here, if you have a computer, if you have internet access, and if you haven't already received or downloaded the SDK, go and do that, and then check out some of these resources. The final thing I want to show on the website is a bunch of hands-on labs that there are, and this is great. In fact, let me show you a very quick example of the skeletal viewer walkthrough, if you will. You can download either a Word or a PDF file, and what this is a step-by-step walkthrough of the sample that comes with the Connect SDK. So let me just open it and show you what is inside. And the reason I'm showing you all of this is these are perfect resources for you to explore right after we leave here. So Microsoft and the community around Connect has provided a bunch of resources to sort of take you step by step through the whole learning process. So don't feel that what you see and hear today is sort of the end of the road. There's a lot of support that you can count on. Okay, so while all of that's happening, let me bring up my slides. And the final thing I want to talk, in terms of resources, the final thing I want to mention also is my email address. So my name is Krishna Kumar, and my email address is just my first name dot last name @microsoft.com. So if through the course of the day or after today, if you have any questions that has not been answered and you cannot find what you're looking for in the resources we looked at, please definitely feel free to reach out to me. I'll be more than happy to help answer your question. If I cannot, then I know a few folks like Stuart and a few folks in the actual product development group that can help answer the question. So one way or the other, we'll make sure that your questions are answered. And the reason again is because we want you to be involved in the Connect space. It is, basically the power of the community that's going to make the ecosystem really rich. And so we want to see how you take this and where you take Connect. So with that, I'm going to step right in. I'm going to skip through some of these positive feedback, and all of that. As you can imagine, it's been huge, right? I mean, the potential of Connect, everybody realizes it's just going to be one of those big, game-changing products. You saw some of the videos before the session began in terms of some of the things that you can do with the Connect, which just a couple of years ago was almost impossible, right? Imagine a small, simple consumer device like this being able to do really sophisticated things, like not just give you a video image like a webcam, but also give you 3D data, direct 3D streams, and more importantly, be able to do things like skeletal tracking, so understand the human shape and figure out what the human shape is doing. All of that really, a couple of years ago, was unimaginable in a non-researchy or a very non-exclusive setting. But today, everybody has one of these things. And at the price point that the Connect sells for, between $100 to $120 US, and based on the statistic that Stuart showed us in terms of Connect being the fastest selling consumer device in history, we can pretty safely assume that this device is going to be one of those pervasive devices. It's probably going to be as pervasive as a TV is today. So what that means for you as researchers, as future developers, is that you can build experiences that can be consumed by a huge variety of people, right? So if any work that you do here has a really large audience, so I'd really encourage you to think about it that way. And we've tried to make it really easy for you to target the Connect, right? So it's not just on one specific language or one specific IDE that you can use. We've basically made it available for both managed developers, unmanaged developers, or whether you program in C++, C and C++, or any sort of .NET language like C# or VB, or even any of the other .NET languages like F# or whatever, you can target Connect, right? And we've basically made sure that any investment you made in learning Microsoft technologies is directly transferable to the Connect. So for instance, if you would with Visual Studio to build, games or websites or anything, the same experience, the same tool set can be used to build Connect applications. So any investment in the Microsoft developer technology space translates directly to building GUI applications, natural user interface applications on the Connect. Additionally, we also saw a bunch of samples and resources that are provided. And the URL I should mention again is this redirects to the new URL, which is connectforwindows.org. So let's get to look at what is on the Connect and inside the Connect for a few seconds. So you're seeing a Connect in front of you, and you're also seeing a picture, but let's look into some more detail into what there is. As you can see, there are basically three reticles, if you will, right? Three ports. And it seems like there's three cameras, but basically what's happening is the center one is just a plain RGB camera. It's almost like a webcam on your computer. It basically looks at the scene in front and returns a color feed in RGB format, red, green, and blue format. The surrounding two reticles, this guy and this guy, are actually a combination 3D camera. And the way it works is, on the left here, this is basically a 3D projector. It's a very small laser, it's a very low power laser, infrared laser that emits a pattern in the scene in front of it. And if you're concerned about, well, it's emitting infrared and is it safe and all of that, let me assure you by saying that the power of the infrared laser is a fraction of what the infrared we receive just by heading out in sunlight, right? So you receive orders of magnitude more infrared by just stepping out of this building than from this laser, so it's perfectly safe. But what happens is, this laser emits an infrared beam into the space in front of it, and this camera is an infrared camera that reads the pattern back. And based on the difference between what is projected and what is read back, it'll perceive depth information, which we'll see in a second. There are also, like Stuart mentioned, an array microphone setup. So there's actually 4 separate microphones that are on the Connect. There's one here, and then 3 sort of here. But all of them work as a single microphone, as a single array mic. And we'll see some of the benefits of that in a second. And the final hardware subsystem is actually a motor, a very small motor that's in the base right here that allows the Connect to swivel up and down. So that if the Connect needs to get a better view of what it is seeing, it can swivel up or down and so on. But this is basically it. This is all of the components inside the Connect in terms of the hardware, right? There's nothing else that we aren't showing you. Everything else that happens is sort of the magic of software that we will explore in a second. So just a quick summary of what we saw. A regular camera, a 3D camera, which is a projector and a receiver system based on infrared, a microphone array, and a tilt sensor, a tilt motor. So the one thing I want to mention is the pitch. If any of you is wondering how much does it go up and how much does it go down, it's plus or minus 27 degrees. So it gives you a total angle of movement of about 54 degrees up and down. So let's take one step closer to how the actual 3D depth sensing works, right? This is, when somebody looks at the Connect for the first time, 2 things really stand out in terms of what Connect can do that nobody else today in the commercial space can do. One is, cheap 3D sensing, right? Inexpensive 3D sensing, and 2 is skeletal tracking. So the way 3D depth sensing works is very similar to the way the human visual 3D sensing works. The way humans actually perceive 3D is most of us, or all of us have 2 eyes, and the image that comes across to our left eye is slightly phase shifted from the image that comes across from our right eye, right? Because they're a little apart, images are slightly apart as well. And so what happens is the brain actually can see the phase shift, and from that shift make sense of the 3D space in front of the human. The exact same principle is at play in the Connect, right? We look at how the projector and the camera work together. Basically, the projector projects a beam, and the projector projects a known pattern in the scene in front of the Connect, and the camera reads the pattern back. Now, the pattern actually is going to be distorted or deformed based on the 3D scene in front of it, right? So, and we've seen this happen, right? Imagine just a regular projector like this. Now, if there's no, if there's no object between the projector and the screen, you basically see a clear image like this. But if I were to walk in front of this scene or in front of the screen, part of the image falls on me, and then part of the image falls on the screen, and there's a distortion that you can see. And so based on reading that distortion of projected images, Connect actually can calculate the 3D scene in front of it. And this, I want to emphasize this because a lot of people have this misconception that the Connect does 3D sensing using time of flight, which basically is how long does it take a projected beam to come back to the Connect. It actually does not do time of flight calculation, it does distortion-based calculation. So this is basically what the pattern looks like. It's normally invisible, but if you have an infrared lens or an infrared camera, you can actually see the pattern as it gets projected out. This is what it looks like. And if you look at it closer, it's just basically a bunch of little pixels that are spaced apart in a known pattern. That's basically what's happening. So that was some of the technology inside the Connect. To actually start programming a Connect, obviously, you need to be able to connect it to your computer and install the SDK. The one thing I want to mention is some of us actually, if you buy a Connect packaged with an Xbox, you probably need another cable because the connector only is meant to connect directly into the Xbox. Now this will change with the new hardware that Stuart talked about that is coming soon. But if you have a Kinect today that came packaged with your Xbox, your connector is not a USB connector. It will not plug into your PC. So what you'll need is a separate cable, which is what I'm picturing there, that basically has a Kinect connector and a USB connector. So it acts as a power cable and as a bridging cable between your Kinect and your PC. But if you got your Kinect standalone, you already have this cable. So that's one thing I wanted to mention because sometimes people come and say, does it plug into my PC? What do I do? So I just want to explain that. Don't force it in. Right. Okay, so once you install your Kinect onto your PC, it's just like any other USB device. Windows will actually install the drivers and make the devices ready to use. So with that, let's take a brief look at one level deeper inside the Kinect, and this is sort of a dissection of the Kinect, if you will. When you take the top off, and you take the cover off the Kinect, this is what you see inside. It's basically, it has what seems like 3 separate boards, right? 1, 2, and 3. But it's actually just a single board with all the components on it. Now, because such a big board wouldn't have fit, it basically sliced it and put them in slices with connectors underneath. But basically, the hardware just is what we looked at. It basically has the VGA camera and the infrared projector and the infrared receiver. These are what the actual components look like. And I'm showing you this just because you don't have to go dissect yours and see what's in there. The spare finally came through. This is the lab document I was talking about in terms of walking through some of the samples, and you can see how much detail we provide in terms of the sample. So you can basically see it gives you source code, it explains the source code and stuff like that. So provides a lot of information, so check it out. But back to our presentations like that. So yeah, these are the 3 camera components. And so what the camera components allow you to do is literally this. The RGB camera returns a color feed, just like a regular webcam. And the depth camera actually returns a depth feed. It's not exactly this that it's returning. What it is returning is just a series of numbers, right? What the format of the data that comes back is like this. For every pixel that it's reading, for every pixel in the frame, it tells you the distance from the Kinect in millimeters of the nearest object in front of the Kinect. Does that make sense to everybody? Yeah? Okay. So it basically gives you a set of depth information, which you can then take and convert it into an image like this, or use it for whatever else you want to do. So in this case, they've taken the depth information and made it into a monochrome image where the objects that are closer to the Kinect are represented in shades of, in lighter shades, and objects that are farther away are represented in darker shades. And you can actually see this person is standing closer to the camera, and so he appears lighter than the ballerina, who in turn appears lighter than the actual back wall, which is all black. So literally, this is what you get from the depth camera. You get distance readings for every pixel on the frame. So that is basically what you get from these cameras. The other element, like we saw, is the actual microphones, and this is their placement. You basically have 4 microphones, but instead of being uniformly placed, they're actually placed in a sort of a staggered fashion. What that allows you to do is by getting the feed, the signal strength from each of these microphones, it allows you to identify where the speaker is. Does that make sense? Right? If somebody is closer to this side, the signal in this mic is going to be a lot more than the sort of the signal strength in these mics. So the software allows the Kinect to identify where the user is. Like it allows what we call beamforming to happen. So for instance, if somebody is here and speaking, then this mic will pick up a louder volume than this mic, and so the Connect knows that the sound is coming from here. Similarly, if the user moves, we can keep track of where the user is at all times. And this has a big advantage, right? One of the biggest advantages is of having this multi-array microphone and being able to do beamforming is it allows us to do something called sound isolation, right? We can basically identify and isolate the primary speaker from all the background noise. Just because we know where the speaker is, we will focus on that feed alone and sort of remove all of the background echoes. So to give you a quick demo of what that sounds like, let me play this for you. So this is a quick demo of the echo cancellation that happens inside the Connect. So what I'm going to do is I'm going to play you two sound clips. One is the actual raw sound clip. That is basically the pre-echo cancel sound clip, and then the next sound clip I'm going to play for you is the sound clip that you get after it's been cleaned by the Connect.
This is an example of multi-channel echo cancellation, extracting my voice from the game sound.
Right, so this is the actual setup, and then after the echo cancellation happens.
This is an example of multi-channel echo cancellation, extracting my voice from the game sound.
Do you see the difference between the two? You see how much cleaner it sounds, and that's because of the multi-array microphone and the software that's inside the Connect that's doing this for us. So that was basically what we've looked at so far is all about the hardware, right? We've looked at the cameras, we've looked at the feed that comes back from the cameras, we've looked at the microphones, and we've looked at the feed that comes back from the microphones, right? Now, let's sort of see how it all comes together when you start programming and using the SDK. So when you install the SDK, this is sort of a figurative way to look at what gets installed. So the base is obviously your hardware, right? This is the actual Connect device. One of the things you'll see is the Connect device has a USB hub built in because it has, do you remember we talked about how the Connect has 4 separate hardware devices, the VGA camera, the depth camera, the multi-array microphone, and the motor. All of these are separate USB devices. But you only have one USB cable connecting it to your computer. So what happens is the Connect has a USB hub inside, which takes that USB connection from your PC and spans it across all of the different hardware devices inside the Connect. So, and that's the reason, one of the reasons why you will see us mention do not connect the Connect USB port into a USB hub, all of which connected straight into your PC. And this is the reason why, because there's already a hub, it's already going through a hub inside the Connect. And if you basically connect it to another hub, then the bandwidth will become too low to sustain the data streams coming from the Connect. But above the hardware layer, this line basically is sort of symbolizing the difference between the hardware layer and the software layer. But right above the hardware are the actual drivers for the Connect, right? So you basically have drivers for your cameras, the drivers for your audio subsystem, and so on. And above the drivers lie the actual SDK to program the camera streams and to program your audio streams. Now the key thing I also want to mention is for the audio segment, the Connect SDK relies heavily on the audio SDK that ships with Windows, right? Because Windows has for the longest time supported microphones and audio streams and even multi-array microphones. So it basically uses the same speech technology that Windows uses. So what that means is if you're already doing any sort of audio work, if you're already using an external multi-array microphone and you've written programs for that, for about 95% of the functionality, you don't really have to make any changes to get it to run when they connect. Because ultimately the SDK is still the Windows SDK, and so the code will run unchanged. The only programming that you would probably have to do is for the vision component of the Connect. And the top layer obviously is the application you write on top of the SDK. questions so far? Okay. So again, a quick recap. When you install the SDK and start programming the Connect, what do you get? You get two raw streams. You get the raw stream from the RGB camera, from this camera right here, which is the video camera, and then you get the raw feed, depth feed from the 3D camera pair. Apart from the raw feeds, you can also get the skeletal tracking capability. If you turn on skeletal tracking on the Connect, you can also get the skeletal feed from the Connect. Now, obviously, the skeletal feed is a processed feed, right? So what Connect does is inside the Connect, it takes the raw feed, the depth feed, and as Stuart mentioned, it basically analyzes it frame by frame, segments each frame, actually analyzes each frame to see if there's any human characters in the frame, and then for each human character in the frame, it segments it further into different body parts and different joints. And all of that resolved joints is can be accessed by the SDK in your own application. So the point I want to make, and actually to an earlier question of how the SDK is different from OpenNI and all of that, I'd say this is a big distinction, right? Because it's the official Microsoft SDK.